Hi, welcome to the Computing There I Was podcast. I am your host, Richie B. Today I am speaking to my friend Kevin Tyson. Kevin started his career as a programmer at the Rockefeller University supporting medical research. Then he spent a large chunk of time working on Wall Street and being a witness to several historical events. He has retired, air quotes, to New Hampshire, where he uses his technical skills to make local politics better. Hope you enjoyed the conversation. I did. Hi, welcome to Computing There I Was podcast. I am your host, Richie B., and today I'm speaking to an old friend of mine, Kevin Tyson. Hi, Kevin. How are you?
Greetings. I'm doing pretty good.
So my first question is always, how did you get started in computing? How did you fall into computers?
It's hard to say. When I was in the sixth grade, so I was just about 12, my parents got me a gift, which was a mechanical calculator that was masquerading as a garage for Matchbox cars. And I fell in love with it and figured out that it was indeed a mechanical calculator. And later that same year at our in-class science fair, a girl in the class who I was quite sweet on um, demonstrated a analog computer that her father had built for her out of simple resistors and VU meters, basically.
Right.
And that got me thinking about it. And yeah, I was already enthralled in the space program because, believe me, when I was in the sixth grade, it was a long time ago.
Yeah, I remember the space program. I was a space nerd myself.
So in 1969, through sheer nepotism, I got a chance to learn Fortran on an IBM 1130. I took the course. I actually succeeded in getting the cards punched correctly to make the program work. And as you know, given that we both come out of that same generation, this was, backflips through flaming hoopla hoops. But I felt like I had accomplished something. Didn't do anything else with computing until 1975, my last year in college. We got this huge Tektronic programmable calculator. Calling it a computer would be a stretch. But I programmed the crap out of it. And that summer, I got my first job as a programmer at the Community Treatment Foundation, a part of the Rockefeller University.
Oh, so where did you go to school?
I went to Sarah Lawrence College, a small school right outside of New York. At the time, this is the early 1970s. It had only recently, I like to jokingly say, desegregated. Had been a girls' college women's college for many years. Okay. And I think 4 years before I arrived, they had started to admit men. And then in a blast of what can only be termed like private affirmative action, they decided that they wanted to get non-white people on the class into the school too. And they were conveniently located next to the Bronx. So they succeeded in getting half a dozen of us to migrate up to Westchester.
So Rockefeller University, that's in Manhattan, right?
Yep.
So what did you do there?
We were across the street from it because this was the Community Treatment Foundation. It was an organization that was formed to support two purposes. One was to provide patient record management services for all of the drug treatment patients in the southern tier of New York State, and the other was to provide statistical research for Doctors Dole and Nicewander, the two doctors that invented methadone as a opioid addiction treatment modality. I was hired as a trainee. We were on a PDP 15, one of the bizarre threads that the deck reeled out. And even in 1976, it was quite old. It had 3 6-bit bytes. And to give you an idea of how old it was, our line printer was an LPO2. and our terminals were VT05s. As you know, by the time DEC went under, they all had 3 digits after
Right.
the designation. So this was really the early days. This was programmed in mumps, which was also turned out to be one of the great advantages in my career, because I started out in a symbolic programming language that had a graph database behind.
So can you explain that? So the funny thing is,
Sure.
one of the people I interviewed, Katie Munson, in an early podcast, she was one of the developers of mumps on DEC. So she was a little bit ahead of us, but she worked, that was one of her jobs.
Wow. Well, MUMPS stands for Massachusetts Hospital Utility General Programming System, if I remember correctly. And so this was an interpretive language. There was a very small kernel of an operating system, which provided just the most basic services. And so by symbolic programming language, what I mean is, in order to do the things that we take for granted in an actual development environment, because this machine was so small. I mean, physically was huge. I mean, it came in refrigerator-sized boxes, and it had, I think, 16K words of memory. So, as in a interpreted language, you just type in text and it figures out how to get this to be machine instructions. But it also, the interpreter knows about the language. And because the environment was so constrained, for instance, you only had single letter variables. It's like, when I was a little boy, it was uphill both ways in the snow when you had to go out to program. So one of the things that you would have to do is, in order to get a continuation of your job, if you're thinking about it in workflow terms, was you had to write a string, which was the next step to be done, package it up, and tell the operating system, yes, and when I exit, do this. And it also meant that the data in the graph could also just become code. And thankfully, this was so primitive. There were things like SQL injection. Is still light years in the future. I mean, this is so long ago. Database was 2 words. I remember, I'm sitting here in front of my Mac Studio, which has a button. And I remember in that same site, it was either 76 or 77, Computer World ran a cartoon with 2 engineers standing around one of the huge boxes that we associated with computers at the time, with a single on-off button. And one engineer was saying to the others, "We'll see if this is simple enough for them." And of course, here we are.
Right.
This was interesting for a number of this job, and that programming language were interesting for a number of reasons. The guy who had done all the original development, Rod, we forget his last name, was brilliant. And so, one of the things about it being a symbolic language was the editor was 2 lines of code that you inserted at the front of any program that you wrote, and then you would just invoke it when you needed to add more code to the program.
That's interesting.
Yeah, no, it really that in that regard, it did not set me up well for what was to come, but in another regard, it did really well. This was the beginning of my, what's the best way to describe this? I've been the Forrest Gump of finance for almost half a century. So in 1977, the New York City went bankrupt, and they couldn't pay the drug treatment clinics. And so we did some archaeology using open reel tapes, concept which is alien to most of the human race today, to reconstruct data, and we actually saved them $1 million. And on the one hand, you could say that this was back in '77 when $1 million was still $1 million, but this then set me up for my first job interview on Wall Street, where I walked in and they showed me the kind of reports that I was going to have to produce. And the numbers they showed were much, much smaller than the numbers I was used to seeing in my Medicaid reports. And I commented on that. He laughed and said, "Yes, that's because we only count millions of dollars in this application when we report." It's okay. You have my attention.
So what bank was this that you...
This was Citibank, when it was still known as Citibank. They had only recently introduced the automated teller machine.
Right. Were they the first
And
ones to do that?
no, actually, it was like some tiny bank up here in New Hampshire, but they were the first big New York bank to do it.
Mhm. So what was the coding environment there? Was it COBOL, I
Oh,
assume?
no, no, no. This is right after a guy who is unsung hero of computing, Teddy White. He was a senior vice president at Citi, and I believe it was the 36092, which he had figured out looking at its capabilities versus what IBM was going to lease it for, that this beat the pants off of the next more powerful machine. He leased lots of them. IBM figured out that this is what was going on and exited the lease agreement. So he called Ken Olson and
Right.
said, send me PDP-11s that
Right. Ken
normal
Olson,
people can program.
for our listeners, Ken Olson was the, I guess, CEO or chairman of the Digital Equipment Corporation, right, who were the competition to IBM at the time. And the other thing you should mention, which is obvious to us, but at the time, you did not buy computers, you leased them from IBM.
Yep. So this introduced a wave of what were known as departmental mini computers. Again, for the younger members of the audience, we're talking about refrigerator-sized boxes. We still called them departmental mini computers. They existed on raised floors, and they were the reason that Citi developed the culture that it did, because by bringing in all of these strange new computers, they brought in strange new people to operate them. And up until that point in American finance, the IT side of the shop was kind of an afterthought. The people who got paid were the people who made money, and they tended to be like, stereotypical white men. And suddenly all of like these, non-white men and even women started showing up along with the mini computers. And it was interesting to watch Citi respond to this, because, we're talking back in the 70s and 80s, and I saw incidents where senior management of Citi stood up and did the right thing in terms of sexual harassment of women and gays. It was actually kind of breathtaking to see, while they were still going on doing the rest of the American monopoly finance capital kind of stuff.
So what kind of applications did you do?
The very first application that I supported was a letter of credit. And this is really quite shocking for me because, having grown up in the Bronx, I knew about junkies, but I didn't know about finance. My parents, being incredibly left-wing, had left me with this a rather stilted notion of how banks and capitalism in general, and banks in particular, should be working. And on my very first week in the office, they were explaining to me what a letter of credit was. The audience, letters of credit are financial instruments which date back to the Medici. I mean, this is, if how did people in Europe get stuff from India without the internet? They used letters of credit, which were quite similar, in spirit to the way the Islamic world transfers money around the world. There was an agreement between banks. You would go to your bank and say, I need to pay this guy off in literally Timbuktu, if he does the following things and delivers the following goods. So they gave us that as, this is how letters of credit started. But here in the 1970s, of course, they're also used to fund the drug trade and mercenaries. Just to have them give me the explanation. Wow, I thought we would try and cover that stuff up. After I got trained on how to maintain the software, the Sandinistas took over in Nicaragua. And this caused a tremendous capital flight out of the country. Jimmy Carter was the president at the time. So he wanted to stop this. So he was prepared to declare a Rule 13 on chips. So chips is the clearinghouse interbank payment system. It's how, particularly back then, big Wall Street firms settled up at the end of the day. Rule 13 was very, very interesting given the way we now all deal with distributed computing. It was a rule that said that your This is, of course, years before commercial internet. So this was a bunch of point-to-point connections. So you had to have a computer in Manhattan that had a dedicated line to the chip's office, and you had to demonstrate, amongst other things, that your network point of presence could replay a day's traffic, excluding certain classes of transactions, which sounds like a very reasonable thing to do. It becomes unreasonable when you realize that behind the network point of presence are all those COBOL systems that we were laughing about before,
Right.
which kind of think that there is now and there's only now, and we're not going to go back to this being yesterday.
Right.
So Walter Wriston, who was the chairman of Citi at the time, and now I'm going to forget another name, Paul Volcker, got on. Paul Volcker literally went across this uptown to 399 Park Avenue, sat down with Walter Wriston. They got on the phone with Jimmy Carter and explained that if you make us do this, you will end capitalism as we know it, because it will take us years to unravel the mess. So let us handle this. And so they got Jimmy to step back from the ledge. He said, handle it. And one of the ways it was handled was my boss walks into my cubicle and says, I need you to do something. Go into the data center, and I need you to pull some transactions out of the database. Yeah, no problem at all. I am a technologist. I have no idea what the implications are for what I'm doing. He gave me the list of things to look for. I wrote, and this was pre-SQL. This was a database when database was 2 words. So I wrote a little program that pulled it out. And of course, this kind of activity is against the law now, but it saved the day then because we were able to hold back the transactions from going through. And that was so that was that one. And then the Shah was overthrown, and another wave of letter of credit insanity. At my next job at a different bank, I actually accidentally killed somebody with the computer. We built a FX trading system, and we did not thoroughly test the do not send the statement to the client functionality, and we ended up sending a transaction log to a client in Argentina when the colonels, I forget if they were colonels or generals, were running the dictatorship, and had put significant currency controls in place. And we indicated to them that this guy had violated them, and we never heard from him after we sent him his statement. Yeah. That was unpleasant. But like I said, I mean, I'm the Forrest Gump of finance. I have succeeded in getting through these horrible things myself. Okay. Everybody else, not so much.
At some point, you worked on this software called TMX, which
Yes.
I forget what it stood for. So there was
So transaction management executive.
Right. A consulting company that developed this. It was actually quite brilliant piece of software, and I used it in my work for quite a while. So can you tell?
That was, in fact, how we met in the fall of 1983. You were working at Irving, and I was working for Precision Business Systems, who had bought the TMX source code from TMI. And I never knew what TMI stood for, because the people who had worked there only referred to it as too many idiots. But Bill Donner was not an idiot.
TMI was the one that built the similar stuff on PDP-11s, right, in Pascal.
Yes.
Right. So we used that as well. Yeah.
Yep. And Bill Donner was the brains behind both the original PDP-11 code and the conversion to VAX. This was and again, you had to be Forrest Gump. The part that I contributed to TMX was the distributed queuing facility.
Right.
It was, and again, in retrospect, I had no idea that we would be as influential as we were. By the end of the 80s, when things happened on Wall Street, trillions of dollars went through software that was underpinned by our infrastructure. We took a job with Citi to replace their funds transfer network. at the time, the way the Glass-Steagall was still in force, and one of its constraints kept banks from doing branch banking outside of the state in which they were headquartered, which made it very difficult for banks to mitigate risk. And so what Citi did was do a lot of overseas stuff. And they put together what was the world's largest funds transfer network at the time. And I know now funds transfer network sounds like something that would happen in a James Bond movie. What we're talking about is like, KSR teletypes and grass huts, in the third world. And which led to some actually interesting software development. But it was a transaction management system in the days before relational databases. So unless, like someone had IMS experience, it was very unlikely that they were familiar with the notion that you could do a bunch of actions against data on a computer and have them all either happen or not happen.
Right.
Let alone that you should be able to reason about the order in which things happen so that you're always maintaining consistency. But we managed to pull that off. We mainly sold the product into banks. The most colorful place we sold it was a pari-mutuel betting operation in Brazil, which our mutual friend Bob Hasker built for them. And one of the reasons why it was so memorable was they brought their team to New York for training. And I had been in Brazilian restaurants, but I had never dealt with like real live Brazilians, let alone the young, beautiful, attractive ones. And I remember coming in, having another mutual friend, Ken Nichols, walk out of the classroom, look at me and said, "You're going to love this." I walked in to teach them about the queuing system. And in the front row were these two girls. One was obviously, rich brown skinned Brazilian woman in a camisole so that her nipples are completely visible, sitting next to an Asian woman who is also completely Brazilian and similarly dressed. But, they did a great job. They learned the stuff and they worked with Bob to build the system. And I have no idea when they turned it off, but it was very successful.
So from that time, remember Bank of New York was using the TMX and
yes.
for securities clearance, and had an interesting blow up. And I remember that we were sitting together in the office when you got a call.
Yes.
So can you tell that story?
Oh God. Yes. In fact, it's funny for a number of reasons. So yes, the Bank of New York was I believe at the time, premier government security clearance operation.
Yes.
So we have to break this down for everybody because they may just be technologists and not know what those words mean. Government securities, this is, bonds, bills, and notes. The way the government raises money is they sell these securities. They sell them into a market of primary dealers, which are the giant banks. And what Bank of New York was supporting was the secondary market. So once Citi and Goldman and everybody else has bought up an entire issue of U.S. debt, they would then start trading it with the second tier. In the secondary market, it's important to maintain your anonymity. So the auctions that the BONY would have, Bank of New York would have, were known as Dutch auctions, in which you didn't know who you were bidding against, and the settlement, took place anonymously at the end of the day. The Bank of New York, as you may remember, was sometimes referred to as the Bank of Grinding Poverty. Yes. And when we moved them onto the VAXes, we explained to them that, this was great in the 1970s. My watch says it's the 1980s. One of the things that we've invented in near recent term is keyed access to information as opposed to indexed access to information. In the system that it existed, which was written in COBOL on top of TMX, the securities index, the unique identifier for a security traded on the system, was a 16-bit 2's complement number. And at the time, this is the beginning of the 1980s, when we had horrendous inflation, and hence everybody was issuing securities, debt-backed securities like you wouldn't believe, with Sallie Mae and Fannie Mae, et cetera, et cetera, et cetera. the rate at which the security master was growing was giving us, the technologists, pause because we knew how horrible it was going to be and how much time and hence money it was going to take to fix this. The Bank of Grinding Poverty kept on saying, no, 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 no. You and I are hanging out. The phone rings. And what has happened is the security master wrapped. In the anonymous auction, people are now getting different securities than the ones they agreed to bid on. This happened, if I remember correctly, on a Thursday.
Yes.
So the multiple weeks of work that we had proposed to do to upgrade the system had to happen that night so that the system could come up, we could issue the reports, and they'd be up for business the next day. And we actually almost pulled it off. But, almost only counts when, you're targeting H-bombs and hand grenades. So that when the system came up on Friday, it took in securities and then crashed. And this Friday was, of course, a triple witching hour, which I don't have to go into the details, but it's when various, the period of various financial instruments that most people would never have any interest in or encounter all occur on the same time. So there's a lot of transacting that goes on. This created such a problem that the Bank of New York had to borrow $23 billion from the Federal Reserve because part of their deal of being the clearing agent was they could have no securities on their books, and they had come up and had a day and a half's worth of securities on their books. I know in this day and age, $23 billion sounds like, a pea hole in the snow. But
right. It was real money.
Back then, I mean, back then when the software we were building was moving trillions of dollars a day, and $1 trillion was still $1 trillion, $23 billion over a 3-day weekend was a tremendous price for the bank to pay. And because of the nature of the accounting and when it happened, people got different cost of living adjustments to their Social Security as a result of this computer error. I remember on the Friday after we had been in the office on Thursday, I went back to where I was working at Citi, and the head of that project looked at me and said, "Didn't you take me to the Bank of New York before you sold me this pile of shit?" And there was something about the way he said "pile of shit" that I knew this was a bigger problem than I had anticipated. And I was right. It became congressional investigation. Bill had to go to D.C. But it was another one of those Forrest Gump experiences. If I was standing there while they were slaughtering other people.
Right. And this is such a stupid thing.
Yes. I mean, it's completely avoidable. It was, what was this, 15 years ahead of Y2K. There was no need for this to happen at all. And then 2 years later, we had the flash crash of 87. And that was fascinating because I was then working at Citi. And again, knowing nothing about finance, I'm in the data center. And I noticed that there are a lot more people in suits and ties in the data center than one usually sees. And the number keeps growing. And indeed, the traffic through our system was growing. And, thankfully, using the exact same approach that we use today in the cloud, we brought more VAXs into the cluster. We had plenty of headroom. We didn't lose any. We didn't drop any messages. We didn't blow any payments. It was just, the system did what it was supposed to do. The senior executives mopped their fevered brows after the day was over. And we actually got a compliment from, I forget who the head of the Fed was at the time, who pointed out that we had not induced any latency into any of the payment systems. And we hadn't dropped any transactions.
Very cool. I mean, TMX was a pretty cool system. Like I worked at Irving where we had it, and Irving actually was taken over by Bank of New York because we were competition in securities clearance. And I was the guy at Bank of New York when vendors would show up saying, "Look, we have this wonderful transaction system. You should be using ours." And I would say, "Okay, does it do that? No. Does it do this? No. Does it do that? No, well, I don't think so. And
It
as
was
far as I
remarkable.
know, TMX was at Boney till at least early 2000s, at least.
Yep. Oh, yeah. And likewise at City, it was difficult for them to drive a stake part of the thing because as the world moved to, risk-based Unix systems, what didn't move along with it was the ability to handle asynchronous communications. And there is still thousands and thousands of those point of sale systems which dial up with your credit card number. And many of those are still being answered by faxes because the KMF 32 will give you 32 telephone lines where, doing this with your laptop is not going to work.
Yeah, one thing we were doing when I was at Bank of New York, we were trying to experiment with like Unix and try to replace TMX with something. And we built a prototype, but it didn't go anywhere using, like a relational database and stuff. Mm-hmm. But accidentally, I think we invented microservices. So I didn't realize this till fairly recently, but basically we would say, well, such and such has to happen as a transaction. Well, then let's put it into a service. And then we had a whole bunch of those.
And it's amazing how many different kinds of things the distributed computing aspect and the communications, the capabilities that it brought to the developers, that's not given that we did not have the internet at the time, was remarkable. In 1986, I did my first overseas business trip. I went to Japan and built a fax message switch, and that was remarkable too because Bill and I arrived at Narita Airport as the Japanese Red Army rocketed the British Embassy in honor of Chuck and Di arriving. As you can imagine, this kind of disrupted a lot of things. I was supposed to meet Bill in the airport, so I arrived on a different flight. The door opens, and there is a literal teenage mutant ninja turtle standing in front of me. There's a Japanese police officer with armor and a bow escorting us out. I had to clear customs with open reel tapes and have a customs agent hold the tape up to the light and in a heavy Japanese accent asked me, software on tape? I said yes. Cost me a couple of 10,000 yen and we were done. But this worked out well because everything was so messed up. We had to take the bus in from Narita, and a Japanese woman sitting next to us on the bus struck up a conversation, explained to us where we had to be for our 9:00 meeting the next day, where our hotel was, which lines to take, where to stand on the platforms in order to be able to get on the right train, which resulted in us walking into the Sunshine 60 building 5 minutes ahead of the meeting. And they were flabbergasted. Well, how did you get here? We took the subways. How did you know to take the subways? We're New Yorkers. We grew up on the subway. At the time, this was 1986. The world was enthralled with Japan Inc. They had just bought the Rockefeller Center. They were the new Ubermen that were going to take over. And that was the attitude. I showed up thinking that these guys just completely show me up here. Started going through the standard course on TMX, and I would stop every couple of minutes because I knew arigato and I think one other word of Japanese, and I explained it. I don't speak Japanese, so I'm going to speak English very slowly, and I'm going to stop and ask you questions all the time. We got through the first day, and I was the rumors were right. These guys are fucking machines. They're just sailing through this material without any questions at all. The next day, I asked them some spot quiz questions, and it was clear that nobody had picked up anything. But being Japanese, they were not going to embarrass me by saying, no, we don't have the slightest idea what you're talking about. I had a couple other faux pas like that because this was Japan and it was the 1980s when they wanted to interview me for the company newspaper. The newspaper was, of course, done by a woman who did not have good English skills. So one of the male engineers, and she took me out to one of the many amazing lunches that we had. She started off by asking me, how do you find the girls in Tokyo? To which I said, well, that's kind of an embarrassing question for a pretty girl to ask a married man, which which immediately made the male engineer want to kill the woman who was there. And it made it worse. My wife has me very well trained. Everybody's teacup was empty, so I grabbed the tea thermos and offered it to them. And the male engineer said through clenched teeth, "In Japan, women pour the tea," while he was glaring at the reporter who was supposed to be interviewing me. But all in all, it was an amazingly successful trip. We beat out like 2 Japanese-based, VAX consulting companies. They loved the work we did there. They liked hanging out with me so much that a couple of months later, they almost gave me a heart attack. We were having a staff meeting at PBS. The phone rings, and it's Japan on the phone looking for me. I think something horrible must have happened. They need support for what is for them the middle of the night. I get on the phone. They are at the bar that we used to hang out with, and the bartender told them to tell me hi. So they called to say hi. A couple of weeks later, they came and gave me a gift. They had sent more people for training, and the gift they gave me was a first-generation Discman. I will hold on to this thing forever. It takes 18 AAA batteries and can play for about 20 minutes.
Still, yeah. I saved an article from Daily News from the 1980s that was talking about the Japanese coming 5th generation of computers and taking over with AI and expert systems and stuff.
Yep. Yeah, that was right around the time that I started getting involved with expert systems. I took a prologue course at NYU, and then at City had to learn Ops 5 so that we could program, because that DEC was using Ops 5 to manage their network configuration tool. We had a tool, I think it was the KMF32, which had not been loaded in. So we got to play around with Ops 5 to see how it is that expert systems can fail.
So can you explain expert system in 25 words or less for the listeners?
Yes. The idea being that you should be able to have normal people who are experts in some field or endeavor be able to state succinctly what the rules are for something to happen. So it could be a doctor giving you the rules for a diagnosis. It could be a mechanical engineer telling you the rules for, the ISO quality assurance. In my particular case, I when I got started, I was just getting my feet wet with Prolog, and I started using a tool called ART-IM. And so what this did was give you an expert system where multiple people could be asserting rules at the same time. So it was it was leaning towards the kind of AI that we now all take for granted.
Right. I think the idea was that the system you would ask it a question and it would apply the rules to try to derive an answer.
And even if you didn't ask a question, if whatever stimulus you gave it, if it was data arriving or what have you. So this was during the AI winter. So it's very funny to watch how this happened over the end of the 80s for me. At Citi, at their funds transfer network, one of the things that they wanted to do was not pay people to read telex messages and then type them into a form, because Citi has, since the 70s, been on the leading edge of technology, and the battle cry was technology was going to save the firm. They figured that this was an application of technology. So they hired a guy who was a department head at Yale to come in with a bunch of his grad students and a Lisp machine, which was actually 2 PDP-11s strapped together, to write code based on a data structure called an augmented transition network, to be able to read the telexes and create C structs, basically. They went on for month after month after month, and they didn't produce anything. And then finally, they handed this project over to one of the many women that Citi had been promoting into senior management on the IT side, who asked this guy for a project plan, because she wanted to know when the project was going to deliver. And he said, and I quote, "We would love to deliver a project plan, but delivering the project plan would negatively impact delivery of the project." So he was accelerated to approximately 9 meters a second. And she turned to us, the rest of the technologists, and said, well, can you help? See what they did. And these guys, so they did their work in Lisp. For those of you who are unfamiliar with Lisp, it is a programming language which is actually a formalization of the Turing machine, so that it allows you to program at a level which is just unobtainable in regular old programming languages. And because it was so attractive to so many smart people, it got lots of features long before everybody else, like macros, so that you have to write very little code. So when these guys got thrown out of city and had to deliver the work product, they expanded all the macros. So it just came in as, yeah, ooh. They were not happy. City was not happy. But what we discovered was, we took a step back and took a sample of the messages. And we realized that for many of these institutions that were sending us messages, they had a piece of paper that looked like one of our messages stapled to the wall next to the telex machine, with the parts highlighted that you had to replace with, the account number and the amount. And that therefore, like 90% of the text was boilerplate exactly the same, and just good old stir-toke in C, and you could do a reasonable job. So we were heroes for, not drinking the AI Kool-Aid at that point. But I still had a chance to mess things up with AI because a firm named Transarc, Alfred
Yes,
Spector,
I heard of them. Yeah.
Built TMX for OSF1. And one of the people he sold us to was Bill Kelvey, who is the CTO at Fannie Mae, who did lots of revolutionary things. One of the revolutionary things he did was bring in a expert system so that mortgage underwriters could immediately find out, just by dialing up from their laptop, whether or not your mortgage qualified. So I kind of helped build the power tools that Fannie Mae used to dig the hole that the economy fell in 2008, which found me working in the fixed income department at Bear Stearns. So I guess what goes around comes around.
Right. For those of you who don't remember 2008, Bear Stearns, I think, got absorbed into JP Morgan.
Yes, that's one way you could describe it. It's an experience that has left me with one rule of thumb, which is never ask, how much worse can this get?
So what did you do post TMX?
So post TMX, that was like the first half of my career. I started out, really like following in your footsteps and focusing on software engineering as a practice. And I got pretty good at it because I had, these wonderful opportunities through TMX to do these interesting things. And all through this, I was trying to figure out why, we got smart guys building software with the best possible tools, and the software is more often than not useless if it's actually delivered to the business. And because it didn't make sense, and I was approaching this from, going all the way back to in the summer of 1976. I read Edsger Dijkstra's A Discipline of Programming, and I read Rodney Zach's book on the microcode for the 6502. So it seemed obvious to me that this was just very, very simple engineering and very simple applied math. And that was the way I approached the engineering side of things. And so my engineering skills kept on getting better and better and better. And the gap between the utility of what I was producing and what the users needed kept on growing more and more and more. The worst example of this is while working as an employee at a bank. Let's not mention which bank. And this is back in the 80s. Our boss went to a Christmas party, and in the men's room, listened to two people discuss how recent tax changes made Puerto Rico a desirable location to do custody management. Based on that information, he had us spin up an entire we called it the Puerto Rico Custody Management Project. We refer to ourselves as the Puerto Ricans because of this, despite the fact that none of us were actually Puerto Rican. And we worked on this thing for months. We did linguistic analysis of the requirements we were able to find and mapped them to, a C++-ish wrapper that we created in VAXC. At the end of the year, it turned out that he had misheard the wrong conversation in the urinal, and that no one needed this wonderful thing we had engineered. We had like traceability for requirements down to all the code, everything was documented. It was useless. So I started to try and understand what the nature of this gap was. So, we're talking about the beginning of the 90s. So object orientation was one of the answers. In pursuit of that, I attended the software development conference in San Jose, which was very funny for two reasons. I took one course with Grady Booch.
Yes, I've done some of this as well.
And he was, dazzling the audience by, citing Greek philosophers and, Aristotle's logic and whatnot. And, having studied Wittgenstein and seeing how Aristotle was wowing these people. So you ain't seen nothing yet. Let's talk about language games. And the other thing that happened at that class, so after taking his class, I engaged him in conversation about this and about, the gulf between the science of understanding formal languages, which we can do with model theory and stuff like that, and doing things with words, the way, the philosophy of language approaches these things. Right. And if you ever want attention from vendors at a software conference, walk in discussing airy-fairy stuff with Grady Booch, arm in arm. I couldn't shake him for the rest of the week. It was, you're the guy that Grady Booch said good things about. The next class that I took was on the CRC method, class responsibility collaborator method. In fact, it was so old, it hadn't been brought to Europe, where the term collaborator has certain negative aspects which caused them to change the name of the course. But this was really influential for me because the other three people that, we broke up into tables, and the project was to do a 4-function handheld calculator. I was at a table with three other people. We had a project manager from the Savannah River Fast Breeder Nuclear Power Project. We had the quality assurance guy from a medical implants company. And we had the guy who was responsible to quality assure the code in the HB printers. So we sat down to do it. Ours was the only design that had error codes. Working with these guys was a real eye-opener, because when you do safety critical systems, when you're sending software out in the world that you don't get to send bug patches to, it's a different approach. As the object-oriented world took off, and I got more involved in requirements analysis, I also started working with the object management group. I got involved with their architecture board, where with Chaim Kilov, we started the Behavioral Semantics Working Group. And our goal was to add the specification of behavioral semantics to the interface definition language. What does this mean for normal people? Okay, so I'm assuming that your audience is going to be familiar with opening a file, writing to a file, reading a file, closing. So if you're going to close a file, it should be open. It's a behavioral requirement. You should be able to specify this where you're defining the function signature for closing the file. Similarly with read and write, it's got to be open, etc. And you can imagine that you can start making more and more sophisticated constraints. This falls naturally into the work of somebody else I know you're familiar with, Bertram Meyer,
right,
and Design by Contract. In pursuing this stuff, again, more on the language side than the software side, I got involved with several projects where actually understanding what the user needed became paramount, more important than having the software be the fastest on the block. One was a accounting module for a over-the-counter swaps trading system. So I think we'll just say that swaps is an exotic financial instrument and leave it at that. And over-the-counter is usually pronounced OTC, which in this case was kind of funny because the guy running the project was French. And so he would refer to it as OTC. And so the project became Odyssey for the English speakers in the team. And so I was able to use a functional programming language, standard ML of New Jersey, within a simulation framework to prove all of the accounting rules that we were extracting from the requirements document, and use this to communicate to the programmers who were writing in C++, which at the time had very few abilities to do the kind of checks that we need, what kind of checks they would have to create by hand. So, from that, I got more and more involved in semantics. And for most, I love saying it this way, for most of the century, I have been involved with semantic web and other semantic and language aspects of IT. So the first half of the career kind of mirrored Wittgenstein's Tractatus, and the second half was more philosophical investigations and language games.
That's cool. So, in light of all that stuff, what is your opinion on like today's AI, especially in LLM stuff?
I make extensive use of it on a daily basis. I have retired. Well, like I said, I'm failing at retiring, but I have moved to rural New Hampshire, where it's completely different than the other 49 states in so many ways. Like it says on the license plate, live free or die. The whole code is live free or die because there are fates worse than death. And, this isn't something that they've recently adopted. This is a genuine attitude they've had since day one. For instance, the state constitution, unlike the federal constitution, which it predates, has the Bill of Rights up front instead of tacked on at the end. And Article 10 says that if the government becomes oppressive, you are obligated to overthrow it. So we're a pretty wacky bunch up here.
Yeah, I've read some books about...
we do things on a very small scale. We have, I think it's 452 members of our House of Representatives, which means that each representative only represents about 3,400 people. And you know where they live, their telephone number, their email address. You can reach out to them anytime you want. And that's at the state level. At the municipal level, it gets even more insane. We have our city council. So our city has approximately 13,000 people in it. It has a city council with 7 members. Likewise, we have a school board, which has 7 members and are selected by the people in the community who bother to show up at elections. We have, for time immemorial, an open meetings law so that everything gets published, largely in the form of PDFs. And also we video all of the open public meetings. So what I've been able to do with LLMs are take the videos, turn their transcripts, which generally speaking, because of the technology they use, don't correctly identify speakers, and actually turn them into dialogue, conversations between identifiable speakers on identifiable topics. Link these to the agendas, any supporting documents that the meeting is going to be focused on, and link these into the specific locations in the video where they are mentioned and being discussed, and then to be able to compare what people said versus what was said in the meeting documents, and to compare all of that against the state laws governing education, the Department of Education's regulations about how things should be done, and the federal regulations. And that for a long meeting takes about an hour. and produces a level of integrated information that folks here have never had exposure to before.
Great.
So I've
That's
been doing
like a
that.
great application of AI,
Yeah, it's no, in my Substack refer to it as asymmetric information warfare.
So my last question, as always, is if somebody's starting in the field today, what would you advise them?
Oh, God. The last time I tried to answer this, I was speaking at an organization in the South Bronx, which has locations around the country. And what they do is take people who are at the bottom rung of society and have struck out. And these are people who are drug treatment patients, ex-cons, and it trains them to be desktop support people, network support people, to have actual, hands-on IT skills. And so I was working for J.P. Morgan Chase, who was providing them with both financial support and a website that they used. The name of the organization is Par Scholas. So I had met them at, in fact, I met them at 101 Barclay with doing a presentation. And, for those on the line, that's where Richie used to work. And, so I saw what they were doing online. So I introduced myself to them and said, this is great because, I grew up in the hood right next to the hood where you're doing this, and I would love to help. And they said, well, we have a career day coming up. Why don't you come and speak to us? Because JP Morgan is so sensitive about, their name and, their presence, I had to get my career talk approved by like somebody that reported to Jamie Dimon. And all it did was it didn't talk about JP Morgan at all. It talked about IT. And so I made a terrible mistake in that presentation. So this is what not to do. What I told them was they should be able to separate out the skills they need, the formal languages they need in order to do the networking stuff, and the natural language stuff that they need in order to be able to listen to people and know what to do when they're in the formal language world. And so I advised them that, the Tractatus was good for formal language and philosophical investigation was good for natural language. So don't do that. But I would say that, particularly now, because of the conversational interfaces that are being offered by literally I'm waiting for my car keys to start, asking me questions when they start out. Given the prevalence of these conversational interfaces, it's really important to get a handle on language. It's more important than figuring out which programming language to use. And the answer to that question is Python. But it's really going to be particularly with the ease with which these tools crank out code, unless you're really dedicated to, having a folk song written about, how you died driving the spikes while the AI was cranking them out. It's better to figure out how to listen to people and speak to them, speak to the LLM precisely and get what you need, what you want out of it.
That's interesting advice.
Well, earlier this year, I had to take a for a training company. They had a curriculum, and they had become convinced that semantic web would help them manage it, and we demonstrated that we could. But I took a 550-page PDF file that I never read and was able to reduce it to 3 different formal structures. One which was the representation of the document as a flowing document. One was a formal representation of it as a curriculum with learning objectives and the Bloom taxonomy stuff. And a third as the format that they would need in order to be able to crank out videotapes and handouts and teachers' notes and stuff like that. I never had to read the document itself. This used code that either worked on my desktop or in the cloud, and it ate up the amount of data that it ate up just as text was staggering. So the way that you and I came up with the past of being the smartest, hardest working guys in the room who knew the technology, those days are gone. I mean, everybody hates us boomers. The thing they should be hating us for is we have pulled up the ladder behind us. All that stuff that we learned getting here, we can now say in a couple of words to a machine, which has already inculcated all those lessons that we learned, and with very little effort on our part, will turn out immense machines.
Yeah, I have some reservations about what the LLMs can produce, but yeah.
One last comment.
Yeah.
I had an interesting experience last week. I had to write my first MCP, which was easy to do because I did it in Python. And halfway through, I was looking at it and I realized that in 1994, ISO issued a specification which covered all of it was called the trader portion of RMODP. And it described everything that, the MCP has to do when we're negotiating and explaining what it is that, the meaning of the information that could end up. And then the other acronym that hit me was ACPs from RSX 11M, the thing that made access, it was, going from the semantics of your code to the semantics of, cylinders and sectors.
All right. So this was about an hour. This was great. Thank you so much.
You're most welcome.
And to our listeners, hope you enjoyed the conversation and come back next time.